David.
Thanks, Andrew. Well, good evening, everyone. Welcome to the last meeting of 2025. Just a few short announcements before we start. I've got a few events taking place early in the new year. The first one takes place on Thursday the 8th of January, which is our beginners group, which takes place at Acre Road, which is run by Chris and Warner. Chris is down in front here. The subject for the month will be planets, comets and meteors. So that's 7:30 to 8 p.m. The next event takes place the evening after, or Friday the 9th, which is a stargazing evening at Murdoch Park. Our own members will be there helping out. Tickets are available via Eventbrite, 7:30 to 9 p.m. The next event after that takes place on the following Sunday, the 11th of January, which is the Observers Group. This is a Zoom event, which is presented by Robert down at the front here. Again, 7:30 to 9 p.m. A Zoom link for that will be sent out near the time. And the final announcement is membership fees. This is the last opportunity to pay your membership tonight and to be able to enjoy the benefits of society membership. And I think our treasurer, Ewan, is here tonight, in the middle of the audience here. So that's all the announcements for tonight.
Okay. Thank you, David. Well, not quite all. I've got one myself. As you know, for members, we have for the last few years had scheduled observing nights out at Etmo, Murdoch Country Park, but we've had to change that because Murdoch can't give us a room, for a warm room to stay in. So if it's cloudy, people go out there, which only a few people ever do if it's cloudy, then there'll be nowhere warm and dry. Well, it'll be dry, but it won't be warm in the observatory. So we decided to change that, and we're now going to do impromptu observing. That is, if it's clear and people are free, then we go out to Murdoch at more short notice to Etmo. That will be, usually that's been self-arranging in the WhatsApp group, but we'll also notify people via the Facebook group as well. And if there's anyone that doesn't use WhatsApp or Facebook, then please let us know and we'll send emails out to those who don't use social media. So that's going to be in the new year. For people who like scheduled events, we're looking at maybe doing daytime events out at Murdoch, so people, members of society, can come and look at the telescopes. I think we're thinking a Sunday afternoon once a month is what we're looking at, and then it won't matter that it's cold because you can go to the cafe, which will be open. So that's what we've got planned for that. Okay, so do let us know if you'd like to be notified. Members would like to be notified by email rather than social media. And that, I should also say, before I introduce our speaker, who's waiting very patiently, our calendars, it's your last chance this year to buy our calendar. All photographs are taken by members of the society. Many pictures now are taken up at Etmo and by the telescope in Etmo. It's £10 for the calendar, and all proceeds go towards helping continue Etmo and run the society. So very grateful for any purchases there. Still a few left. So, it's my pleasure to welcome Dr. Vassilios Strathopoulos, who comes to us tonight to talk about quite an interesting historical subject. But he has a PhD in aerospace engineering from the University of Glasgow, and is currently teaching in adult education for the Edinburgh Council, courses in astronomy, and is a fellow of the Royal Astronomical Society. And I've certainly heard of this talk before, but never seen it, so I'm really looking forward to it tonight. I should also say we're having a sign language interpreter, British Sign Language interpreter. So, for a member of ours. If anyone knows anyone who's interested in astronomy and is a British Sign Language interpreter, do let us know, because that would be a very good thing, wouldn't it, Sarah? So, without further ado, can I introduce you to our speaker tonight and tell us about the Antikythera Mechanism.
Okay. Okay, thank you very much for that introduction. Thanks to everyone for braving the infamous Scottish weather in December to come and listen to me tonight. I normally joke about this when I'm starting a talk. Probably the most difficult thing, the most difficult part of my talk will be trying to pronounce my full name. It's pretty long, as you can see there. The full name is Vassilios Strathopoulos, and I've got a long Greek complicated name and a bit of a Scottish accent because I'm a Greek Scot. Okay, so I grew up in Greece. I went to school there. And then I came to do my studies here in Glasgow, actually. So I'll just tell you, I won't bore you with this too much, just one slide about what I do, who I am. Some of it has already been mentioned. I've got a PhD in aeronautical / aerospace, I guess, engineering from the University of Glasgow. I've worked at various universities. I started off in academia in Greece. I was a lecturer there in aeronautical engineering a while ago. I currently teach at Glasgow International College, which is affiliated to the University of Glasgow. It's a foundation course for international students. I used to be responsible for the engineering program there. I mainly work part-time now, just do a bit of teaching. In the last 10, 15 years or so, I developed a great interest in astronomy. I started reading about it, I started learning more things about it, and eventually reached the point that I could apply for funding to do outreach events. I also tutor at the Edinburgh Council Adult Education Programme, and as I said, I've been lucky enough to get funding from the Royal Astronomical Society and the Institute of Physics mainly, to go to schools, to go to science festivals. I've been all over Scotland, parts of Greece, and even to the Netherlands as well, to do some astronomy outreach there. Because of this work, I was elected Fellow of the Royal Astronomical Society about a year or two ago as well. So, what is the connection between myself and the mechanism, which I'm going to be presenting today? Basically, it's an obsession I've had for years now. I first read about it, I don't know, over 10 years ago. Initially, I couldn't understand much about how it worked or what it was. I had a sort of very general idea. But the last several years, I've been studying it, and I've been presenting it to many different occasions and venues, as I said, throughout Scotland, but even Greece as well. Though it's quite famous in Greece, not everyone knows what it actually did. This is me at a school last year on the island of Kythera. So Antikythera is an island, and anti literally means opposite. So the big island is Kythera, where I am there at the school. And you can see the sea behind me. Somewhere way back there, the mechanism or fragments from the mechanism were found over 100 years ago. Right, but before I actually talk about the mechanism itself, let me tell you a little bit about ancient Greek astronomy. Because it didn't come out of nowhere, this. Okay, you've maybe heard about it, ancient astronomical computer. But the ancient Greeks had already developed astronomy for hundreds of years before the Antikythera mechanism was built. So some of the things they did, they theorized on, they were the first to actually theorize on the essence of the universe, its form, its substance, that kind of thing. One guy in particular, Anaximander from the 6th century BCE, so a long time ago, was the first to think of the Earth floating in space. Now that seems obvious to us now, but it was a big leap forward in those days. Also, contrary to what some people might still believe, the ancient Greeks had solved the shape, the matter of the shape of the Earth from the 6th century BCE. Probably Pythagoras, you maybe remember him from your maths at school, from geometry. He possibly was the first to postulate that the Earth was spherical way back in the 6th century and the BCE. They also applied geometry because they were the first to use geometry in such a sophisticated way and applied geometry to astronomical problems. Some of the major ideas, I've already mentioned Anaximander. He's considered the father of cosmology. Pythagoras, I've got a question mark there because we're not quite sure if it was him or one of his pupils or disciples that actually came up with the idea of a spherical Earth. Another guy, you maybe never heard of him, Anaxagoras. He actually correctly interpreted the reason that we have eclipses. He also postulated that the sun is a mass of red hot metal. Now, he said it was larger than the Peloponnese. That's a region in Greece. And that might seem a bit silly to us now, but if you look at the sun, it doesn't look that big in the sky. He realized that it was quite big, and the known world was quite small at the time as well. And also you've got to remember we're at the time of Zeus and Hera and Aphrodite, and yet there were some people who had realized that there were more scientific explanations that they could use. They also realized, Anaxagoras, that the moon actually reflects the sunlight and that the moon is an earthy lump. Okay, Heraclides of Pontus, another guy that's not that well known, but 2,500 years ago, he proposed that it's the Earth that rotates about itself. The mainstream view was that the heavens rotate, and that was the mainstream view for hundreds of years after Heraclides, but he thought of this a long, long time ago. And probably one of the most famous of all, you might have heard of him, Aristarchus of Samos. Why is he famous? Because he proposed a heliocentric theory 2,500 years ago. And of course it wasn't accepted or proposed again until Copernicus in the 16th century. And finally, another very famous astronomer, Hipparchus, he actually realized that the Earth axis wobbles, what we now call the precession of the equinoxes, and lots of other things he did. Created a star catalogue, and also used geometry to provide the first estimates to the sizes and the distances of the moon, the sun, the Earth. Actually, some of them were really accurate. So they got the size of the moon and its distance from the Earth pretty accurately, the size of the Earth as well. A guy called Eratosthenes, who was a librarian of the Alexandria library, he got that to within less than 10% of the correct value, 2,500 years ago, just using geometry. Just think about that. The Greeks, I have to say, every civilization, every culture builds on other cultures. They built on observations, as we will see later in the presentation, of the Babylonians. The Babylonians are considered the first sort of meticulous observers of the sky, and they provided the Greeks with a lot of data, we would say nowadays. And of course, most importantly for this presentation, they designed astronomical computers, one of which was the Antikythera Mechanism. So let's concentrate now on the mechanism itself. A timeline here. It was constructed round about the 2nd to 1st century BC. So it's over 2,000 years old. It was on a ship, on a shipwreck that was wrecked about 60 BCE. So an ancient shipwreck that was found just over 100 years ago, 1901, by Greek sponge divers. They were just off the island of Antikythera one of them dived in and apparently was terrified. He came up saying, "Oh, I've seen all these bodies and arms and heads," but in fact it was parts of statues that he had seen. You can see some in the bottom there. I'll talk about those in a second. So between 1901 and the 1970s, there was speculation, because on the shipwreck they found, apart from the statues, some fragments, the largest of which is the one you see there. And they looked pretty strange, but nobody really had a clue what exactly it was. So some people thought, well, maybe it's a navigational instrument or an astrolabe or a planetarium type thing. In the 1970s, a guy called De Sola Price, an English physicist, he started studying it extensively, and he used X-ray images for the first time. And he published a very influential piece of work, Gears from the Greeks, and he produced the first models which were starting to approach what we now know of the Antikythera mechanism. In the 1990s, a guy called Wright, who was the curator of, I think it was a science museum in London, one of the big museums in London, and a guy called Bromley, who unfortunately passed away a few years ago, they used X-ray tomography and further researched the mechanism to reveal more features. And then in 2005, there was a major breakthrough. An international team, they used state-of-the-art CT scans to provide even greater detail. Apparently, they used lorries to transport the equipment that they used from Britain to Greece in order to study the mechanism in detail. So this gives you an idea a little bit of the geography. It was found just between the Peloponnese and Crete. Some of you might have been to Crete for your holidays. But it was probably, as I will demonstrate soon, built in Rhodes, another famous tourist destination. But it gets even more complicated, most possibly for a client in northwest Greece, way up there, a region called Epirus. And I'll explain why we think all of this. So the wreck itself is very important. Apart from the mechanism, it's one of the most important shipwrecks that's ever been found. It yielded numerous statues, jewellery, coins, from which we can date the shipwreck as well. Coins are very important in this case. And some of the findings date from even further back, the 4th century BC, but also fragments of a strange mechanism. And once they started to use CT images, the magic would occur, and they could start seeing through these blobs of bronze, essentially. And they started seeing teeth, and they realized these were parts of gears. And once you start measuring the teeth and you see numbers, then astronomers relate these numbers to astronomical cycles, and they start understanding what these things were doing. So, what we now know is that nothing of this technological complexity has survived from antiquity. I'm not exaggerating. That is the truth. Nothing like this has survived from antiquity. Doesn't mean nothing else like this was built or invented back then, but it hasn't survived. Dozens of gears, remains of 30 have been found, but most scientists believe that there were a lot more, possibly even double the number of gears. Dials, inscriptions, and it was used to perform detailed astronomical calculations. Some people call it the world's first analog computer. This is a reconstruction of what it would have looked like. So it's a unique archaeological find, as I've said. It's given us a completely new insight to the capabilities of ancient people. And what is interesting is that it encompasses the achievements and the knowledge of several cultures. Babylonians, Greeks mainly, but also there's even an ancient Egyptian calendar on it, believe it or not, and I'll explain why. It's a product of what we call the Hellenistic culture. And this is when Alexander the Great created his empire. It stretched from modern-day Greece up to northern India. And this is when the Greeks primarily got into contact, the Greek culture, if you like, with the Babylonian culture, the Indian culture even, the Egyptian culture. And there was this fusion of ideas that gave astronomy such a boost at this time. So this is the layout here. You can see, well, what is even better, actually, I haven't mentioned it yet, probably now's a good time. I brought a model of it, which you can have a look at the end, and feel free to take pictures as well. I've got 3 models. This one here is actually half the size of what the original mechanism would have been. Okay, so just imagine that. But I like this one a lot because it has everything. It even has the little doors. You can see it had little doors as well. And it had a front part, a rear part, 2 little doors, and most probably some kind of lever that the user would use to set the date. And all sorts of inscriptions you can see have been found in Greek, of course. So the front panel mainly contained a calendar and the zodiac, which actually it's probably best I show you the pictures here. So there's a picture of the front panel. To the left is the original Greek version. To the right it's translated into English. And you can see there's 2 the main 2 circles here. The outside circle is an ancient Egyptian calendar. So the names are written in Greek, but they're actually Egyptian months. And this was quite a simple calendar. It had 12 months of 30 days, plus 5 extra days as well. So 365 days in total. Now, that doesn't make it particularly accurate, as you probably know, but it's simple. And astronomers like the simplicity, because it was you didn't need to add any leap years or complicated months like we have now, 29, 30, 31, whatever days. It was very straightforward. So if you want to compare 2 events, it was very easy to do that using this calendar. So this calendar was used by astronomers apparently up until about 400 or 500 years ago. And that's why it's on the mechanism. It's the calendar that the astronomers would have used. Not the everyday people in Greece, but the astronomers would have still used that. And the way the mechanism worked, there was a dial there that showed Helios, the sun, and they would set that to the month and the day of the year that they were interested in, and that would turn all the gears, and all the other dials would turn and show you what you were interested in. So the second circle there is the familiar zodiac cycle. You can see there's Taurus, Gemini, all the usual signs. And this acted a bit like a planetarium. So it would show you where the sun is. Currently it's in Aquarius, for example, and Selene, the moon, is in Taurus at that particular date. It also had a little ball that would show you the phase of the moon. It's currently a crescent, a gibbous moon there. It would go through all the phases throughout the lunar month. Now, this is not shown here, but it's almost certain that the planets, the known planets at the time, would have been shown as well. The gears haven't been found, but we've got lots of clues that the planets, the position of the planets was probably shown on the zodiac cycle as well. So it would tell you that Mars would be in, I don't know, Scorpius, for example. And also you can see some letters there and some Greek words. These are, that's a bit like what we would call an almanac, I guess. It's telling you when certain important stars or constellations are appearing or disappearing throughout the year. Okay, so that's what that's doing. It's a little table of stellar events. Right, let's go now to the back panel, which is even more interesting in my opinion. So again, I think it's best I show you the stuff here. Another calendar, this one. This is based on the Metonic cycle. Some of you might know, I won't go into too much detail what that is, but essentially these are names of ancient Greek months this time. And this is the calendar that everyday people would have used. Now, one thing that complicated things, but it's good for us because it gives us clues, is that each city-state in ancient Greece had its own calendar. So imagine that if you moved from Athens to Sparta, a different calendar. But it's good because we can tell from the calendar here, gives us some information. So that's good for us. There's another little dial there to the right, the one to the right over there, that's interesting. It just shows you that it wasn't just astronomy that this was concerned with. This shows you ancient games, the most famous of which, of course, are the Olympic Games. Olympia, they're on there as well. Olympic Games are every 4 years. The dial is showing us if it's going to be a year with Olympic Games. There's other games as well that it tells us about, and one of them is particularly important. I'll get back to it later in the presentation. This is one of the most amazing features of the mechanism. So in the lower part of the back panel, there's another spiral indicator like this here. You can see it, and the little boxes are months. Again, some of them, most of them are empty, but some of them have letters. And you've got to think there would be an indicator a pointer pointing to one of those depending on the date. Everything turned depending on the date. So if the pointer pointed to an empty box, then nothing happens in that month. If it points to a box with a month, let's say, with inscriptions, then interesting things happen. So the one that's shown there is a sigma. You see the Greek letter sigma. That stands for Selene. Selene is the moon. And what it's telling us is that there's going to be a lunar eclipse during this month. It tells us the other, I won't go into too much detail, but the other information it's telling us is the time of the eclipse. Okay? If it's eta instead of sigma, it's Helios, it's a solar eclipse. So the mechanism could actually predict eclipses, which is quite amazing if you think about it. But the Babylonians had actually sussed this out before the Greeks. So the Greeks were building on Babylonian knowledge in this case. They had realized that if an eclipse occurs on a particular day, then 223 lunar months later, that's about 18 years, 11 days and 8 hours after that eclipse, a similar eclipse will occur. You can check that out if you use something like Stellarium. I do that in my... It works like magic because you can just count the years and the months and the hours, and you'll see the eclipse happening again. This is the Saros cycle. Some people may have heard of this. It doesn't last indefinitely. eventually there's a small error there that accumulates essentially. But the Babylonians and the Greeks later and others used the cycle extensively to predict eclipses. Okay? Now, you'll notice that there's an 8-hour shift each time. Well, the mechanism takes this into account, and it tells the user with one of the little dials that was on there that, oh, you need to add 8 hours now. Or if you've gone through the cycle twice, you need to add 16 hours. So there was this as well taken into account. Now, why did ancient people want to predict eclipses? Very simply because they were terrified of them. Especially the Babylonians, they were terrified of lunar eclipses for some reason. And they had this practice, believe it or not, where the king, the Babylonian king, would step down if they knew an eclipse was happening. So imagine how important it was to be able to predict them. They would use a substitute slave or someone like that for 100 days. He or she, I don't know, would live the life of a king, literally. But after the 100 days, I don't want to think what might have happened. Anyway, so that's the main parts. There's also the little doors, though. And the little doors, believe it or not, act like a user manual. They even had a type of user manual, or a description, might be a better word, of the mechanism. And that is where we get a lot of the clues. For example, it tells us about the planet cycles. So probably there must have been planets on there as well, even though we haven't found the gears. Now, how did it all work? Well, that gives you, that's a schematic diagram here. You can also Google this kind of thing and you'll see all sorts of animations and stuff happening, but you can see that for yourselves. I think it's better you spend more time today maybe looking at the model, which you probably don't get a chance to see that often, but that's the kind of complexity. Look at the gears in there. Quite incredible. And there's some features that when I first read about them, I honestly couldn't believe that this was the case. So, first of all, it's the first case that we know of differential gears being used. Essentially, I'm not an expert on this kind of stuff, I'll admit that, but essentially what differential gears do, in this case anyway, they can subtract things. And if you subtract the position of the moon from that of the sun, you get the phase of the moon, in simple words. Okay? That's one thing. But what is really incredible is that the mechanism took into account the following. We know now that the moon doesn't go around the Earth in a perfect circle. It's an eclipse. It's an ellipse, sorry. Sometimes it's closer to the Earth, sometimes it's further away. When it's closer, it speeds up. When it's further away, it slows down. This is Kepler's second law. Okay, most students of astronomy, or all students of astronomy, will have studied Kepler's 3 laws. Now, the Greeks didn't know about ellipses or about Kepler or anything like that, but they had realized through observation that the moon speeds up and slows down. They had realized that, and they'd measured it. But not only that, they implemented it on the mechanism. So the moon doesn't go around in a steady speed, it slows down and speeds up depending where it is in the sky. Which, when I first read about that, and there's a special little mechanism inside the mechanism that implements this irregular motion. Right, a few questions that I normally get, so I decided to put them into a slide. I'm sure I'll have more questions, but when was it built? I've already covered this, between 2nd and 1st century BCE. Where was it built? Possibly Rhodes, and the clues are from the games. There's a set of games, the Alea games, that are I'd never heard of them before, but apparently they used to take place in Rhodes. Also, there's some astronomical settings that correspond to the latitude of Rhodes. So that points towards Rhodes, Who built it? Well, another reason that we think Rhodes is a contender is that many famous astronomers of the time lived and worked in Rhodes. A guy called Posidonius, Hipparchus that I mentioned previously, a guy called Geminus. They are important astronomers or scholars of the time. In fact, Cicero, the Roman scholar, once wrote in one of his works that our friend Posidonius, one of the guys who worked in Rhodes, as you know, has recently made a globe which in its revolution shows the movements of the sun and stars and planets. So something, maybe not, he's maybe not referring to mechanism itself, but something similar at least had been definitely built in Rhodes. Where was it to be used? Now, although all this information points to Rhodes, there is one clue that points to somewhere else, and that is the calendar. Remember I told you each state, each region had its own calendar, it's Epirus, and in particular there was a Corinthian colony in the northwest of Greece, and they used that calendar that's on the mechanism. So the theory goes that it was built in Rhodes, but for a rich, important client in the northwest of Greece. Speculation, we can't be sure, but that is what most science researchers believe. Were there other similar devices, people ask me, and the answer is yes, definitely yes. There's more than a dozen references to similar devices in ancient texts. One by the famous Archimedes, the guy who found the law of buoyancy while he was in his bath, and then he ran out naked shouting, "Eureka, I found it, I found it." He had built one of those, but he lived before the mechanism's time. They used to think that he might have been the actual guy behind it, but it turns out he was about 150 years before the time of the mechanism. Now, what was it used for? There's all sorts of theories here, okay, and I don't want to take sides, but my favourite one, maybe because I do it myself, is that it was used for astronomy instruction. And it makes sense, and one reason that it makes sense is that there was a textbook written then by Geminus, one of the guys I mentioned, that was used as an astronomy textbook. We know that, and it has survived. And it more or less, the mechanism more or less follows what is in the textbook. So there is a strong chance, in my opinion, that this was used by some astronomer in order to teach his pupils about astronomy. Of course, it could have also been, or maybe at the same time as well, a status symbol. That is a very strong possibility also. And, you know, various other theories have come up, but my favourite one is that it was used for instruction. How accurate it was fairly accurate in general. If you think about 2,000 years ago, it could get the position of the sun and the moon to within about a degree, which is pretty good. Not so great for the planets, because a guy called Ptolemy, who came up with a sophisticated planetary theory, didn't arrive till 200 or 300 years later. So probably, although again there's speculation about this, and I don't want to take sides. Some people believe that because the planet gearing is not there, you can come up with all sorts of theories about it. Some people believe that they could have been more accurate, but the sort of mainstream theory is that for planets like Mars, it would have been out by maybe even 20, 30 degrees. But for other planets, probably much better. The eclipse predictions were probably to within an hour or two of the actual timing of the eclipse, which is pretty impressive for 2,000 years ago. Okay? Now, some people ask me, what happened to this technology? Did it just disappear? Because the actual type of gearing and complexity seems to, most people think, suddenly reappeared in the 1300s with those grand astronomical clocks, like the one in Prague or in some of the cathedrals here in Britain as well. Actually, though, some sparks have been found in between. So to your left, you see a geared Byzantine calendar. Now, this is the Eastern Roman Empire from the 6th century CE, and it showed the position of the sun and the moon, if I remember correctly, and several other things, but it was much, much simpler than the mechanism, nothing like the mechanism, but it did use gears, we should say. And also, the one to the right is a geared astrolabe, an Arabic one, or Islamic astrolabe, from the early 13th century. It survives, although diagrams of geared astrolabes exist from much earlier. So, again, you can see how much simpler it is on the mechanism, but there were some sparks, so maybe this technology that suddenly seems to have reappeared in Europe in the 1300s, maybe it built on these sparks that still existed. So we're slowly coming to the end of the presentation. Where can you see it today? 82 fragments have been found. That's the largest one in the middle there. And they are kept in the National Archaeological Museum of Athens. If you ever go to Athens, visit the museum. There's a room dedicated to the mechanism. It's really worth. I try and go. I've been 3 or 4 times. I try and go a bit like a pilgrimage, if you like, when I'm in Athens most times. Several models exist in museums and university, and as I said, I've been lucky through funding to be able to acquire some. This one here you can have a look at the end. I've got another one that's actually been set to the current epoch, if you like, and it works. It can still predict eclipses. This one here, you can see the dial at the back. It's about to enter a month with an eclipse. Okay, and it's telling us that it's going to happen on the 15th day of the lunar month at 3 o'clock, and it's going to be a partial lunar eclipse. You go to the front part and it tells you the date. That turns out to be around about the 18th of September. And sure enough, on the 18th of September 2024, there was a partial lunar eclipse. So it still works. I still use it for. This was constructed by a guy in England, so it's one of the other models I have. It's very fragile, so it's not that easy to move about. And to be honest with you, although it works, this one here actually looks more like what the mechanism, the original one, would have looked like, because it has the doors, it has the inscriptions, everything. It's just half the size, remember that it would have been double the size. So, I just want to finish off with a beautiful quotation from a guy called Cassiodorus, a scholar from the 6th century CE. So these mechanisms were still manufactured, or types of this kind of thing, way up to the 6th century CE, and he said that this tiny device is pregnant with the world, being a portable sky, a compendium of the universe, a mirror of nature which reflects the heavens. Thank you very much.
Thank you very much, Vassilios. Predicted how long you would talk for, and you were exactly right. Why am I not surprised?
It was a mechanism.
It was a mechanism. I also owe you an apology, because after checking your name before we began, I read out what it says on the website, which is your surname is Strathopoulos. Of course, your name is not Strathopoulos. We're in the University of Strathclyde.
You still did better than most people do here, so don't worry. Don't worry. It's okay.
Anyway, questions. I'm sure there must be questions.
Yeah.
That's really interesting, thank you. How do you think they made that mechanism? Do you think it was cast or machined?
Well, do you know something? I always get this question, and I like to be honest. Nobody really has a clue how they did it.
Can you repeat the question?
Oh yeah, sorry. So yeah, you're right. So the question was, how did they manufacture the mechanism? Okay?
Thank you.
And unfortunately, it's the only question, if I'm going to be honest with you, we really don't know. In fact...
Use a PC.
Use a PC, yeah. Who knows? I mean, the thing is that we knew that the ancient Greeks could design very simple gears, because they are mentioned. Unfortunately, no one mentions exactly how they were designed, but we had no clue that they could design something this complex. So we really don't know. I mean, to give you an idea how complex it is, there's a gear on the mechanism that we found that survives that has 223 teeth. Okay, now some people here will be more qualified than me to understand how difficult it is to do this accurately. But yeah, I'm afraid the honest answer is I don't know, and nobody knows. If anyone tells you they know, they're kind of speculating or making it up. Okay, yeah.
Do you think it was more than one of these things, Matt?
Yeah, definitely. I mean, so the question is, were there more than one of these mechanisms made? And the answer this time, I can give a definite answer. The answer is yes. I think, if I remember correctly, there's 18 references have been found in ancient texts to this type of mechanism. So my idea is that there was definitely more than one, but the fact that they're referencing them means that they were also quite rare. Because if it was something that everyone had, they wouldn't bother writing about it, if you see what I mean. So the way I see it is it's like a supercomputer all the time. The big labs will have one, but you and I won't be able to afford one. And I think it wouldn't have been the big labs, it would have been the aristocrats or the king or the very famous astronomer, but we're certain that there was more than one around. Yeah?
You'd mentioned the smaller or the different mechanisms of the Eastern Roman Empire and the Arab Islamic Empire, but both of these civilizations built upon the science or the astronomy of the ancient Greeks.
Yeah.
So is there any information or any evidence that they developed these mechanisms through that information they had, or that they did it independently?
So that's a very good question. There's no direct evidence that I'm aware of that they actually took that specific knowledge from the ancient Greeks and applied it to build these mechanisms. But what is undisputable is what you said, that they did build in general on the astronomical knowledge of the Greeks. So it's quite plausible that there's some lost text. I mean, a very small, we don't realise that, but a tiny percentage of texts have survived from antiquity. So possibly there was something that they had that we haven't found yet, or will never find, that they did build on. Because there was a continuation there through the Eastern Roman Empire, the Byzantine Empire, and through the Islamic world as well. The Islamic scholars in particular, they were at one point during the Islamic Golden Age, they were obsessed almost with translating ancient Greek, and not just Greek, Indian as well, Egyptian, but mainly Greek texts. So they are one of the reasons actually that a lot of this has survived at all, because in Europe it was lost for many centuries.
I wonder if it was perhaps lost at the Library of Baghdad, where a lot of this stuff would have been kept, I imagine. It was burnt down and may have been there.
Yes, yeah, and also the Library of Alexandria, that was definitely another disaster, if you like, for our world culture. But at least we're lucky that some of it survived, either through the Arab route, which was southern Spain was part of the Islamic Empire at the time, so a lot of it went through there once the Europeans got in contact with that part of Spain, and also from the eastern side, as you mentioned and I mentioned, the Eastern Roman Empire as well.
Thank you.
Okay, yes?
Is there any evidence that there were ever similar devices for calculating other things, or was it only just astronomy?
So that's a good question. During slightly after the time of the mechanism, I think it was about 100 AD. Oh, sorry. Yeah, the question was. I keep forgetting. I really apologise. The question was if there were mechanisms built for other things other than astronomy. And the answer is yes. So around about 100 AD or CE, depending on what you want to use, there was a guy in Alexandria, a guy called Heron, Heron of Alexandria, and he was very famous for his mechanical inventions. And one of the things that he invented, these haven't survived, but references to them have survived, was something like a primitive steam engine, believe it or not. So just imagine if that had been advanced way back then. I mean, the steam engine was something that fueled the Industrial Revolution in 1700 years, 1600 years later. So there's a museum in Athens which is called the Museum of Ancient Greek Technology, and if you go there, you'll see all sorts of inventions like this steam engine I'm talking about, or another famous one is this pigeon apparently that used to fly using steam, all sorts of things like that that haven't been found, but there's references to them, and I think in some cases there's actually diagrams that have survived as well. So they were similar. Somebody once asked me, did the Greeks mainly philosophize, drink wine and theorize? Well, that's the kind of stereotype you get, but they actually invented practical stuff also, not just the mechanism.
They're also great architects.
Yes, yeah, exactly, and great sailors, so they were great at building ships as well.
And great writers.
Yeah.
Is there any ongoing research happening with this mechanism, or is just like after 2005 just finished?
Okay, so the question is, I'm getting better at it. The question is there any ongoing research on the mechanism? The answer is yes. So there's two things I can say about that. One is that divers are scanning the shipwreck every year almost, and last year they found some statues, I think, or jewellery or something like that. Unfortunately, nothing related to the mechanism has been found for a long time. But they're still diving, and you never know, there might be something there that we're missing. Maybe the signature of whoever built it or whatever would be good. The other thing is that there's not quite a few, but there's some issues that are outstanding still, and there's not a consensus. For example, the Egyptian calendar that I talked about, I should have been probably more accurate, but very recently, I think it's a group in Glasgow University actually, they've come up with a theory that it's not a solar calendar like I described, 365 days, but it actually was a lunar calendar, 354 divisions. So there's these kind of debates still going on. The main debate is to do with the planets. Because the gears haven't been found, you'll get one camp that will say, we can't be sure that the planets were on at all, we can't be sure about that at all. And then you've got another camp that say, oh yeah, they were there and we know how it was designed as well. So there's different outstanding debates, but at the same time they're still diving underwater and trying to find stuff. So maybe one day it'll be on the news that they will find something new. Yeah.
Would this have been a thing? I hate to say this bad word, astrology for astrologers.
Yeah.
Looking at the horoscopes.
Okay, so very good question. The question is, would it have been used for astrology? And the answer is, first of all, that astronomy and astrology, and you're not going to like this, but it's true, were the same thing in those days. The divide didn't happen till 300-400 years ago. Kepler, the great Johannes Kepler, was an astrologer himself. He came up with Kepler's laws, but he also believed in astrology. And the ancient Greeks certainly did. And first of all, they would have used the position of the planets and that kind of thing for horoscopes. I'm certain of that. But also on the eclipse prediction, there's the type of eclipse, the hour, and then there's some obscure things like the direction of the wind and the colour, and we're not too sure what these are, but researchers believe that they are related to astrology. But we're not quite sure how. But yeah, I'm sure that... But the two things were, they wouldn't have seen it as something separate. No. Anyway, yeah.
Would it be possible to put up the slide again of the expanded model of the mechanism so that we could take a picture of it?
Yes.
You know what I mean, the coloured wheels to show how it all worked?
Yes. I mean, I have to say...
I just wish I'd had a picture of it.
Yeah, you mean this
That
one?
one,
Yeah,
yes.
yeah.
Thank you.
Yeah, it's a nice picture of that.
Oh, it's lovely.
I mean, I have to say, there's loads of stuff online. If you go onto YouTube, for example, and you Google simulation of Antikythera Mechanism, you'll get brilliant animations. I thought, because you can find that stuff yourself, I thought it's better any time we have it now at the end, you can have a look at the model, because this was constructed by a research team in a Greek university, the Aristotle University in northern Greece, and it's not easy to get your hands on this type of thing. So I think it's a good opportunity for people to have a look. It's normally museums that you have to go to see this. So have a look at that at the end and take photos of that as well. I would say it's probably worth it. Yeah.
Inputs. If you wanted to know the first quarter of next year, what would you put into the mechanism to get the date and the time on it?
So they would have had an idea of the actual date, the day of the year. That they had the calendar there. So what I guess you're talking about is the year, not the day of the month. Because the day of the month, that there was the calendar there, and they would have just found the month and the day, and they would have turned the lever, and it was the sun pointer that pointed towards the date. So that's how they set the date.
So there was an element of cranking the machine,
yes,
like
yes.
Multiple mentor.
Yes, yes. Exactly.
Which order did you use?
I have no idea. But some people ask me, was the whole thing automatic? You know, could it actually turn itself? I mean, they could have done that, I suppose, if they wanted. It's not that complicated. But we think that it was done manually. So they just turned it and set the date. And everything else inside the mechanism turned, and all these dials showed the corresponding celestial phenomena of that particular day. Yes?
Do they know where the elements came from to make the metal?
So, do they know where the elements came from to make the metal? First of all, it was bronze. It was made out of bronze, apart from the doors that were partly wooden, as far as we know. I haven't read anything about that. I don't want to say I'm 100% sure, but I'm pretty sure if that would have been a very significant clue. It would have been flagged up somewhere. So my answer is no, they don't know, but you know, I'm not 100% sure. It's just I haven't ever seen anything like that.
There is a database of isotopes and where they came from. So that would maybe help.
Maybe, yeah. I've never read anything like that. It's an interesting idea, but I would have thought that it would have been flagged up somewhere if they'd done it. But yeah, that's a good point. I hadn't thought of that.
What we'll do is we'll take one more question, but that isn't quite the end because you'd like people to come and look at the
Yes.
model. So we'll take one more question, and then after that we can come down and have a look at the model of the mechanism. So who's the last question? Okay, two last questions.
Yeah.
We've got two last questions.
Okay.
So Billy, you go first.
Yeah, in engineering, if you're not quite sure, even as a draftsman or an architect or somebody, an experienced one, sometimes an apprentice comes up with a new idea. Was it the CT scans or the tomography which gave them a big clue to the crown mechanism, which was enclosed? Because two hands isn't good enough. You need a lot of kids' hands to go one part. Was it due to the international team? They discover where the glue piece and the C piece went? Or was it wrong all right?
So the question is, how did they find out about a particular feature of the mechanism? I can't remember off the top of my head for that particular feature. I know that Bromley and Wright, considering that they didn't have the latest technology, they had come up with some brilliant clues and ideas. I can't remember if that was one of them. Also, the CT scan revealed a lot more detail. So I'm inclined to think it was through the CT, but I can't be 100% certain.
They found a very thin bridge at crater effect, which might have been black glue. Shellac. And then they realised, well, that's what holds it in position. You don't need a little apprentice. Fish holding as you the enclosure. As apart from the easy stuff, like the frames and the together.
I'm aware.
That extremely fascinating.
I'm aware of what you're saying. I think it was the international effort that came up with that, but I'm not 100% sure. I need to check that, but it's a good question.
Sorry, if I can drive in here. If anyone's very interested in this, there's a fantastic book called Decoding the Evidence by Jan Marsh. Came out in 2009. And I've read through it 3 times. It's over 200 pages long, but it's fascinating.
So there's 2 books I can recommend. One of them is the one you just said, so Decoding the Heavens by Joe Marchant.
No, Jan.
I think it's Joe. I'm pretty sure it's Joe. Because I've actually spoken to her, so I'm pretty sure it's Joe. It's GOE, I think. Yeah, I'm pretty sure. But that's the book. You're absolutely right. And then there's another one that's a bit more technical, but it's not, that difficult. It's called A Portable Cosmos by a guy called Alexander Jones.
Oh, I've seen that. I haven't read it.
Yes, it's worth, especially if you've read the other one, this is the next level. It's got diagrams and explains a lot of the stuff that I was trying to explain here.
But the CT scan, I can actually remember that being on news 20 years ago.
Yes, I was in Athens at the time as well.
It was amazing.
And who had the last?
I think it was somebody at the,
I was just going to ask, has anyone looked at whether it's actually possible to use a geared mechanism to describe a retrograde action in the planets? That just seems quite a complex motion to describe with a geared mechanism.
So the question is, has anyone ever looked into using a geared mechanism to describe retrograde motion and planetary motion, which is notoriously complicated to do?
Epicycles.
Yes. Yeah, exactly. So the answer is yes. The guy Wright, I think, was the first one to design a model that could do the retrograde motion as well, and he proved that the Greeks could have done it. And also, there's a team at UCL, a university in London, and they've done something similar also, even more complicated, which gives more accuracy, I think, than Wright's model. But you know, these are speculations, obviously, but it can be done. It can be done. And there's an interesting theory. You mentioned epicycles. So the Greek planetary theory was based on this concept of epicycles. So they had the geocentric model, Earth in the centre, and in order to make that work, they came up with all sorts of complicated motions. So, you know, things going around the Earth and then going around themselves. It worked. It somehow worked, but it was very complicated. And up to now, up till the mechanism was found, people were thinking, you know, okay, they had this theoretical concept, and then they saw the mechanism, and most people were saying, well, they applied the theory to the mechanism, but what if it was the other way around? What if they had the gears first, and then from the gears they were inspired to think, oh, that's how the planets and the universe works. So that's an interesting thought. Yeah, who knows? Okay.
Thank you very much for a fascinating talk, which was crystal clear, and answering so many questions. That might be a record. You did try and preempt them with questions, but they still came at you and you answered them. So let's thank Vassilios.
I got better, but...
And maybe a wee round of applause for Sarah. That was quite tough. Okay, so please come down and have a...
Yeah, if you want to have a look.